A piecewise function is a function made up of two or more different functions, defined for different intervals in its domain. If we look at our example here of f of x, when the values of x are greater than or equal to 2, then we need to use the function x plus 4. However, if we have values of x that are less than 2, then we need to use the function of minus 2x. What we can see is that the inequality, or this restriction that we're placing on the domain for both of these functions within f of x, help us determine which of them we have to use. Now, the reason we use piece functions is that the first reason is that some relations are functions only when we restrict the domain, and also because we can have functions that are actually made up of a bunch of different functions. So my image on the right here, notice that I have almost like a connected roller coaster ride, and for each color is actually representing a different type of graph. So blue is like a linear equation, my red graph represents sort of like a trig function, and then notice that I have curved functions for my green and purple. So notice here that collectively this is f of x, but within f of x we have different types of functions depending on the values that we have all across the x-axis here. So we're going to look at this example here that we looked at before. So what does this actually mean, and how can we actually show what this looks like? So here, the function f of x, well, for x is greater than or equal to 2, I'm looking at the function x plus 4. So what I'm going to start with is on my right, I've just drawn without any restrictions the graph of y equals x plus 4. But because with our piecewise function, it says I only want this graph for x values that are greater than or equal to 2. So what that means is when I jump to my next slide, can you see now that I only have this graph for values that are greater than or equal to 2 along the x-axis? So here, what you can see is that this here is where 2 is. And can you see as well that I've also placed a closed circle dot at the very start? And that's because we're looking at greater than or equal to, so that's including the value of 2. Now, the next thing we're going to look at is we're going to look at the graph of minus 2x. So we're going to start by drawing the graph in its whole form. Then we're going to have a look at restricting it by looking at x is less than 2. What you can see here is, can you see I no longer have the entire linear function, but only from when x is less than 2. And can you see as well I've used an open circle because I have an inequality that's not greater than or equal to. So what this means is that, let's just say I want to find the value of f of 3. Now, in this case, I need to decide by looking at my inequalities, can you see that because 3 is greater than or equal to 2, it fits in the first function here at the top. So then I'm going to use the function of x plus 4. So I have 3 plus 4, which would be equal to 7. Now, let's just say I had f of 1. Now here, can you see that that would actually satisfy the bottom inequality here because 1 is less than 2. So then I need to use the graph of minus 2x. Now, if, for example, I can have questions that where we can combine both parts of our inequalities. So let's just say I had, well, f of 3 plus f of 1. So that means I have to use two different parts of the function in order to evaluate. Now, because I've already calculated these values here and here, what I end up with is 7 minus 2. And that's how I look at a piecewise function both graphically and algebraically.